We're talking electrical force this morning on the morning show, kind of firing things up with our wise guy, Matt Sellen. You're showing us some things we can do at home.
Right. So these are things you can do at home. And so I want to show you a way that you can make a, it's called an electroforce.
Okay.
I don't know, it doesn't matter what it's called because you can just do it. It's kind of neat. All you need are some straws, some plastic straws, a styrofoam plate, and an aluminum pie plate.
Okay.
All these things you can get real easy.
And
if you have a fluorescent bulb, then you can see it easier. But if you're just doing it yourself, you don't really need the bulb because you'll be able to feel the sparks and see them because they'll be right there. It's just a little hard to do that on TV.
Okay.
So what you do is you take the pie plate, which is made of styrofoam, and it's an insulator. And insulators have this property that if you rub them against other insulators, you can transfer charge, and you can leave charge on this insulator.
Okay.
And so that's why I'm wearing this kind of goofy-looking sweater.
Yeah.
Is because it
warm.
happens to be really good. Well, it is kind of warm, but you know, if I rub this thing, I leave a bunch of charge on it, and I don't know if I'm leaving positive or negative types of charge. Basically, when people say that too, it's really only the electrons that move. So if this thing ends up being positive, it's because I put electrons off of this onto my sweater, and if it's negative, it's because I put electrons on. But anyways, that's okay. So now this thing is charged up. Now, if I put this pie plate here, the pie plate has the property that it's a conductor. So electrons will move around in it, and the electrons, suppose that the pie plate underneath this styrofoam plate is negative, okay? That means that the electrons in this pie plate want to get away from the styrofoam plate, so they're going to come up and sit around the edge of this thing, but they can't get off because there's no place for them to go. But if I bring my finger up next to it, I'll get a little spark. Okay. Now, this thing is now, because these electrons jumped off my finger, or jumped off this thing onto my finger, this thing is now positive. So if I lift this thing up, this thing is now positive, and when I bring my finger up next to it...
Ooh, hear that one.
Did you hear it?
Yeah.
Okay, I get a little spark, and I could definitely feel that on my finger. This is where the straws come in. They're plastic, and they are insulators, and that means I can pick up this aluminum conductor without touching it. Okay, so this, when I put this thing down, I get a spark. Same thing. Put your finger up to it.
Yes.
You feel it, right? Okay. Now, if we dim the lights, we'll be able to show you... Okay. If you did, you can look at this thing flash. When I pick this up, and I put this bulb up next to it, you get it. Well, I saw it over next to me.
I saw it, yeah.
You see a little tiny flash. It's a bit hard to see on TV, but it's easier to see than the little tiny spark.
Yep,
okay, so
definitely in that one.
Okay, so you can see the little spark. Okay, you can turn the lights back on. So this is something where, and to make that spark, you need quite a bit of voltage. I mean, you know, you're talking about hundreds to thousands of volts to make something jump a centimeter, and the spark sometimes can be a centimeter if if you do this rubbing. So this could be, you're putting essentially thousands of volts on this thing. However, it's nothing that can hurt you because there's so little charge accumulated that the amount of charge that jumps to your finger is just enough to kind of tickle you a little bit. So it's very safe.
So good do-it-yourself home science projects for people to do.
And another good project, by the way, is to put on a sweater and take it off on a dry day, and you hear crackling and your hair stands up, and it's really funny.
Anyways, and then you get bad hair day, too.
So we're going to do a bunch more electrical things next week with currents and bigger sparks and things like that.
Great. Matt Sellen, our wise guy this morning, experimenting with electrical force. And if you have any questions for Matt, you can go to our email at themorningshow@wcia.com or just go to Matt's website, wiseguy.net. Jen?